Hello, my dear students. I welcome you again. Today we will solve some numericals based on equations of motion. Here is the first question, which reads: A man applies the brakes and brings his car to rest in 1.5 seconds. If the retardation of the brakes is 5 meter per second square, find the initial velocity of the car. Here we have given that final velocity will be zero. If you can think here, a man applies the brakes and brings his car to rest. This means that final velocity will be zero in 1.5 seconds. The time here is 1.5 second. And if the retardation of the brakes is 5 meter per second square, this is acceleration, but this is basically retardation. This means that this acceleration will be minus, okay? Minus 5 meter per second square. We have to find the initial velocity of the car. So we can write the given data. Here we have given that v is equal to 0 because final velocity will be 0 as the car will be at rest at when the brakes are applied. This means that v is equal to 0, and here t is also given, which is 1.5 second, and a is also given. A is also given 5 meter per second square, but this is in minus because this is retardation. Okay, so this will be 5 meter per second square. We have to find u. This means that we have to find the initial velocity. So we can use the first equation of motion. Okay, from first equation of motion. From first equation of motion, we have v is equal to u plus at, which means that here v is 0. Okay, v is 0 here, final velocity, and we have to find the initial velocity u plus a. Okay, and here a is minus 5 meter per second square multiplied by time, and time here is 1.5 second. Second and second will get cancelled. We will get u. I can transfer this u here. Okay, yeah, or I can transfer this one here. This is u is equal to, I can this transfer here, and this will be plus, because this is minus here, this will be plus. So 5 into 1.5 is actually 7.5. Okay, 7.5 meter per second. So our answer is initial velocity will be 7.5 meter per second. This is the second question, which reads: a car starting from rest attains a velocity of 60 km per hour in 10 minutes. Calculate the acceleration and distance traveled by car, assuming that acceleration is uniform. We can write in solution: a car starting from rest. This means that u is equal to 0. Okay, initial velocity is 0 because car is starting from rest. Attains a velocity of 60 km per hour. This means that our final velocity is 60 km per hour. Okay, and in 10 minutes attains the velocity of 60 km in 10 minutes. This means that t is equal to 10 minutes. We have to find the calculate the acceleration and distance traveled by the car. We have to find the acceleration and distance also. Acceleration and distance. Firstly, we will find the acceleration, then we will find the distance also. We can find the acceleration from first equation of motion. Okay, we know that from first equation of motion, v is equal to u plus at. Okay, v equal to u plus at. U here is 0, and we have to find the acceleration. Okay, so I can write here 60 km per hour I can convert this 62 kilometer per hour into meter per second. Okay, meter per second. If you convert this, I will get 60 multiplied by 1000 meter divided by 3600 second. Okay, I can convert like this. V, instead of V, I have wrote this one is equal to U here is 0, so I can no need to write the U here, and A, I have to find A, and instead of 10 minutes I will convert this minute into second. So 10 minute is equal to 10 into 60 is equal to 600 second. Okay, this is equal to 600 second. I can write here. So this is equal to 600 into 0 and 0 will be cancelled, and 600 divided by 36. Okay, 600 divided by 36 will be equal to 16.6 meter per second. Okay, this is 16.6 meter per second, and this is equal to A into 600 second. So A here is equal to acceleration here is equal to 16.6 divided by 600. Okay, divided by 600. Here it's meter. When this second comes from this side, this will go into this division here. So this will be second square. 16 divided by 16.6 divided by 600 comes out to be 0.027 meter per second square. This is acceleration. Okay, this is acceleration, which comes out to be 0.027 meter per second square. Now we have to find velocity. We have to find s. Okay, we have to find the distance here. So I can find this from third equation. Okay, v square minus u square equal to 2as. V square minus u square equal to 2as. And I know here v is 16.6, so I can write here as 16.6 whole square. Okay, is equal to u is 0 and 2 multiplied by a. A here is 0.27. 0.27 multiplied by s. Okay, 16.6 whole square is equal to, this is equal to 275. Okay, 275.56 is equal to 2 multiplied by 0.27 is equal to 0.054 multiplied by s, and s will be equal to 275.56 divided by 0.054, which comes out to be equal to 5102 meter. Question number 3 reads, a bus at rest accelerates uniformly from 54 km per hour in 20 seconds. What is the distance traveled by the bus in 20 seconds? Okay, the bus is initially at rest. This means that u is equal to 0, and then final velocity of the bus is 54 km per hour, and it accelerates to 54 km, accelerates uniformly. Okay, from rest to 54 km per hour in 20 seconds. We have to find the distance traveled by the bus in 20 seconds. So I can write in solution, u is 0. Okay, u is 0, and v here is given, which is 54 km per hour, and 54 km per hour, if I convert this into meter per second, okay, this comes out to be equal to 15 meter per second. Okay, 15 meter per second. This comes out to be 15 meter per second. and and t is equal to 20 seconds. So I had to find the distance traveled by the bus in 20 seconds. Look, we had two equations to find the distance. One is s equal to ut plus half of at square. One is this one, and another one is v square minus u square equal to 2as. Okay, we have these two equations to find the distance. Okay, but in these two equations, as you can see here, acceleration is there. As you can see, acceleration. So this means without acceleration, we cannot find the distance. Okay, without acceleration, we cannot find the distance. And to find the distance, we have to find the acceleration first. So let me find the acceleration first. I can find the acceleration from v is equal to u plus at. Okay, I can find acceleration from this. So here v is given 15 meter per second is equal to u is 0, and a is we have to find a, and t is 20. Okay, t is 20. So I can find it here, which implies that a is equal to 15 divided by 20. Okay, when this gets shifted to left hand side, this becomes here divide 20. So this is equal to 15 by 20 is equal to 0.75. Okay, this is 0.75 meter per second square. So this is acceleration. Actually, acceleration is equal to 0.75 meter per second square. So now I can find the distance. Okay, I can find distance from this equation also, or I can find it from here also. I can find it from here also. I will use this one. S is equal to ut. S is equal to ut. U here is 0. Okay, I will not write this u because u is 0. So S will be equal to 1 by 2 multiplied by a. A is here 0.75 and multiplied by t square. Okay, t square. T square means t here is 20. Okay, t here is 20. So 20 square is 400. 20 square is 400. So this when I calculate this, I get 150 meter. So distance is equal to 150 meter.